Now, if I run this, it looks like it still works, but let me change this to just something random. Right? And so now we can see that no tests ran. So the naming of the function absolutely matters when it comes to auto-discovering tests. And you want to stick to the standard of test underscore something. And I think somewhere in this documentation, it's going to go over, here we go, test from those files, collect test items. So a test prefixed test function or method outside of a class, or a test prefixed test function or method inside a test prefixed test clause. So it's got to start with test, essentially. It doesn't necessarily have to be test underscore. That's why testing underscore add worked just fine. It does have to start with the word test. That's why if I said add underscore test, I don't think this will work actually. Shouldn't based off of their description, and it doesn't. So keep in mind that the naming does matter. And I recommend you stick to the convention of naming all of your testing modules test underscore and the name of the module that you want to test, and then your functions test underscore and then the name of the function that you want to test or the functionality that you want to test. Now, a couple of things to note. I'm going to run this test again, and you'll see that it doesn't really give us much detail as to what's happening, but we can pass in other flags to get a little bit more detail or to change the functionality. So if I do pytest -help, you'll see that there's a lot of options, but I think something that would probably be helpful is like a -v for verbose, and I think we should have that in here. So let's see if I can find that. Here we go. -v is increased verbosity, so we'll just do pytest -v, and let's see what happens. And so now, instead of just having a dot, it's actually going to list out the specific test that's running. So I think that's a little bit more helpful. And I usually like to run these tests with a little bit of extra verbosity, just so that I know what's happening. However, maybe in an automated environment, you don't really care about that. And the other thing to note is that we have this print statement here, but nowhere in the output do we actually see anything get printed out. I don't see testing add function anywhere in here. And the reason for that is that by default, PyTest will not actually print out any of your print statements. We have to pass in an extra flag to do that. So to see the print statements, you have to pass in -s. So now if I run this, we can see that we ran this specific test and it ran testing add function. And so keep in mind, anytime you want to print something, you got to pass in the -s flag. Okay, guys, so testing really is as simple as that. But before we go on to more complicated tests, I want to just make sure that we fully understand how this works. So we're going to create a few more dummy functions that we can use for testings. And if I go back to my calculations.py, I've already written this out, so I'm just going to paste it in here not to waste your time. But you'll see that they all essentially do the same exact thing. They just perform some sort of mathematical operation. So I've got the subtract function, which just subtracts two numbers. I've got the multiply, which adds two numbers. And I've got the divide, which just divides two numbers. So let's test this out now. The first thing that we got to do is, well, let's import all of those. So there's subtract, multiply, and divide. And let's define our function for subtracting. All right. And so just like before, I'm going to do a one-liner. So I'm just going to say assert, and we'll say subtract two numbers. What numbers do I want to subtract? How about 9 and 4? Whoops, 9 comma 4. And we know that 9 minus 4 should equal 5. So I can do assert equals 5. All right. And if I run this again, all right, we can see that both tests pass. And just to make sure that, our testing actually works, let's actually go into our code and let's essentially create a bug. So if I want to add two numbers, right, we know that's going to be num1 plus num2, but let's say, one of our moron colleagues went in and added 1, which is ultimately going to cause our function to break. And so ideally, if everything works fine in our testing, it should be able to catch this. Because if we add 5 plus 3, it's going to do 5 plus 3, and then it's going to add that extra 1. It's going to return 9. 9 equals 8 is going to assert to a false, which is going to throw an error. So if we try this out now, right, we can see that it did in fact fail. And because we set this to be verbose, we can see exactly what happened. So we ran the test add, and what happened was it asserted add 5 comma 3 equals 8. So it's asserting 9 equals 8, and that's going to throw an error. And so that way we see 1 failed, 1 passed, so the subtract function still passed because we didn't touch the code for that. So I'm going to go back and fix our bug in this case. And we're going to just set up a couple more test functions. for multiply and divide. And I can just really just copy these actually. And I'll just change this to multiply, divide, and we'll just select a couple of numbers. So let's say, and I realized, looks like that's a typo. This should be multiply with an L. All right, and we'll say 4 and 3. So when we multiply 4 times 3, that should equal 12. And for divide, we'll change the function that we're calling to be divide, and we'll do 25. So 20 divided by 5 should equal 4. And so now if I save everything, we should ideally see all 4 of our tests pass. So let's try this out again. And you don't have to use the -v or the -s flag. If you're not printing anything or you don't want to see it, you don't need the -s. And maybe you don't want the verbosity, so you could technically remove those as well. And we can see that we get 4 dots, which means all 4 of our test functions have succeeded. If you're like me, the first thing that you may have noticed is that, testing with one set of numbers doesn't seem ultra reliable, right? That doesn't necessarily assure us that the function that we wrote actually does what it's supposed to do. I would ideally like to test with a couple of different sets of numbers. And the way to do that is, well, I'm sure if you just took a guess, right, you're probably thinking, well, maybe we just copy this function, paste it. Well, that should be back here. And then maybe just call this test add 2. Maybe we don't need this print statement anymore. And then you provide the other sets of numbers. So maybe like 4 and 2 should equal 6. And then you try this out and you run this. And we can see that that worked. And technically you can do that, but PyTest provides us a simpler way of doing this. So I'm going to delete this because we don't need that. I'm going to show you how we can do this using something called parameterize. So I'm going to import PyTest. So I'll say from, actually I'll just say import PyTest. And we're going to add a special decorator from the PyTest library. So we say at pytest.mark.parameterize. And so here we can essentially provide a list of numbers that we want to use for testing and then provide what is the expected result. And so, our function takes 2 inputs, 5 and 3, and we also need to provide what is the result. So these are all the values that we're providing. We have 3 values for this specific function. So we're going to tell this specific decorator what are the 3 things that we want to provide for each test case. So in quotations, we'll do num1, num2, and then the expected value. Now, what you call these doesn't matter. It's up to you, right? But these are going to be treated like variables, essentially. So you can call them whatever you want. You can call this X. You can call this Y. You could call this result. It doesn't really matter. But I'm going to stick with num1, num2, and expected. And more importantly, take a look at how this is set up, right? Your instinct is probably to do the end quote here, and then quote here, and then quote here like that. That's not what we want. That is not how it actually works, which I don't know why they decided to do it like this, but that's just what they've chosen. So instead, you remove these, and everything should just be one big string. So that's the first argument into this decorator. The second thing is going to be a list. And it's going to be a list of tuples, and each tuple should represent one specific test case. So the first tuple, we're going to provide our test case values. So we want, what is the value of num1? So in the first test, let's say we want 3 for num1. What's the second one? That's going to be num2. So it's going to line up with what we've put here. So we'll say 3, 2. And then what is going to be the expected value? Well, 3 plus 2 should equal 5. So we just say 5. And so that's our first test. If we want to add a second test, just do comma, add another tuple. And let's just add another set of numbers. So let's say num1 is 7, num2 is 1. We know that should equal 8. And just one more test. And here I'll say 12 and 4 should give us 16. All right. And so now what we can do is we can pass these variable names into our test underscore add function. So I'll say num1, num2, and expected. All right, so you want to make sure these match up with what you've placed here, because if this was called x, then you want to make sure that this is called x. But we'll change that back. And now in our code, we want to replace all of our test values with these variables. So this is going to be num1, this is going to be num2, and this is going to be expected. And so now if I run this, and we'll just do a -v just to see more in detail what's happening. Take a look at what's happening now. We can see that test add ran, and it ran with 325, which is the first test case. It passed. Then it ran the same exact test with these values, 718. That passed. And then it ran with these values, and that ran, and it passed just fine. And then finally, all of the other functions also passed as well. So this is one way of running the same test over with multiple values without having to just define 3, 4, 5 functions and just copying and pasting. It's a little bit cleaner doing it like this. So till now, we've just tested some simple functions, and you'll see that when it comes to testing, anytime you want to test a function, it's actually pretty easy. However, when you're working with classes, it gets a little bit trickier, and it usually involves having to write a little bit more code. So I've created a simple dummy class in this case called bank account, and this represents a person's bank account. And I've already written this out because I didn't want to waste your time writing this out. So if you want to pause this video and just copy down the code so you can follow along, go ahead and do that. But let me just quickly walk you through what this specific class is doing. But like I said, this represents a bank account. So first of all, we've got the constructor. So when we create a bank account, we can create a bank account with a specific amount of money, which is going to be referenced by the starting balance value. And then it's just going to set the balance property of the bank account class to be whatever you provide. If you don't provide a starting value, it's going to default to a value of 0. Then we've got 3 different methods. We've got deposit, which means we're going to deposit money into our bank account. So all we're doing is we're going to pass in a value, and then we're just going to add it to our total balance. Withdraw is the opposite. We're going to subtract a certain amount from our balance. And then collect interest is simple. We're just collecting interest. So here we just take our balance and then multiply it by 1.1, which I guess would represent a 1% interest rate. And so those are the 3 or 4 functions, methods, if you want to count the constructor method as well, that our bank account class has. So I want to go ahead and test this out now. So we'll go to our test calculations. And first of all, we want to import our bank account class. So let's create a test for our bank account. And the first thing I want to test is, let's create a brand new bank account. Where we set the default value, to, the initial amount to be 50. So here I'll say test, and I'm just going to call this maybe test bank set initial amount. I want this to be as descriptive as possible. And so here what we're going to do is, first of all, we're going to create a brand new bank account instance. And since this test is going to test to ensure that we have actually created a brand new bank account with a certain amount of money, I'm going to provide a value. Doesn't matter what value you decide to use, but I'm going to use 50. And we'll just store this in a variable called bank account. All right. And so to test if our function actually worked, or the functionality of our constructor method actually worked, what we're going to do is we just say assert. And we want to check the bank account dot balance property equals 50, because we set the default value to be 50. And if we just quickly go back to our code, you can see that we set the starting balance, or we set our balance property to be whatever the starting balance is. It just happens to be a default of 0 if we don't provide one, but we are providing one, and that's what we're testing. So we can test this. Let's run our code now, and let's see if this worked. We can see that it did in fact work. And just to introduce a bug, maybe we set starting balance to be, -1, right? So we've broken our code. Now, if we run this one more time, all right, you can see it failed because we subtracted 1. So we're asserting 49 equals 50, which throws an error, which means we ultimately failed the test. So let me remove that bug. All right, the next thing that we want to do is let's test to make sure that the default starting balance works as well. So I'm going to create another function, And I'll call this, how about test bank underscore default amount. So in this case, we're just going to create a brand new bank account. And we're not going to pass in a value, so it should default to 0 if our code works. And we'll store this in a variable just like we did before, and then we'll assert. I can copy this. But now it should equal 0. Okay, and let's test this out now. All right, and it looks like it worked, so great. And let's just quickly go ahead and test our last 2 functions out. Sorry, we got 3 more actually, so let's test the withdrawing functionality. So we'll do test underscore withdraw. And here we're going to initialize another bank account instance because we have to do that every time we want to test it. I'm going to give it a default value of 50. It doesn't have to be 50. Once again, you can choose whatever number you want. And we'll store that in a variable called bank account. And we'll call the bank account withdraw method. And we're going to withdraw, let's say $20. So we start out with 50, we withdraw 20, we know that the result should be 30. So if I just copy this assert statement once again, I can just change this to 30 and it should be no problem. Run this. Once again, all of our tests have passed. Let's try the deposit functionality now. So I'll create a test to test that. And I'm actually just going to copy all of this code because it's pretty much identical. You'll see that testing can become a little repetitive. We'll start out with an initial value of 50. Doesn't really matter. We'll change the method to be deposit. Maybe we want to deposit $30. So 50 plus 30 should equal 80. We test this out. Looks like everything's working. And the last thing that we want to test is the collect interest method. So let's create a function for that. We'll do test underscore collect underscore interest. And once again, I'm going to copy this code. And we'll just use it here. We're just going to change the method to interest or collect interest. Okay, so we start out with the value of 50. And so what should the interest be? Well, if I take a look at what my method actually does, it just takes the number, multiplies by 1.1. So that should give us 55, right? 1.1 times 50 should be 55. So I will say this should be 55. And let's see what happens. So if I run this, we can see that we did have one test failed, and I'm assuming it's going to be the last test, the one we just created. And we can see the test collect underscore interest failed. And the reason for that is that it looks like bank account dot balance returns a value of 55.00000001, which in Python is not the same thing as 55. So this isn't necessarily an issue with our code. It's just the way that we're comparing numbers in our test. So this is an issue with our test in this case because it's not accounting for some of the different rounding and the way that calculations occur within Python. So what we're going to do is we can just call the round method right here, and we can round it to 5 or 6 decimal places, depending on how accurate you want it to be. So it should now round it to this value, however many decimals is 5 or 6, and then convert it to an integer. So then we can compare these two because this is an integer, this is technically a float. So they're not going to be equal in that case. So now if I run this, we can see that it did successfully pass. So that's just something to keep in mind. That's why I added that little extra test case, just to make sure that, especially when it comes to those calculations, you got to make sure that you're comparing the right two numbers. If you look through all of the test cases for the bank account, you'll notice that there's some repetitive code. Right? For every single test case that we have for testing our bank account, you'll notice that we always have to initialize a bank account instance. Right? And you can see that right now, look at that. We are repeating our code across all of our tests. And when you get to more complex classes, more complex test case scenarios, right, you might have 50 tests for a single class. And we're, in this case, just repeating the same exact code for each one of them. And so when it comes to writing these tests, PyTest does provide us with some tools that we can use to minimize the amount of repetitive code. And one of those is called fixtures. And a fixture is a very simple concept. It's nothing more than a function that gets run before each one of your tests, or at least the specific test that you want. So we can create a function which does nothing more than initialize a bank account and then return it to our function that's about to run. So I'll show you how we can do that. All right, the first thing we have to do is let's create our fixture, and we can put it anywhere. I'm just going to put it here for now. But generally, you want to put it at the top of the file. Actually, I'll stick to the best practice. I'll say at pytest.fixture. And then here we create a name for our fixture. So I'll say this is going to give us or initialize us a bank account with a 0 initial value. So I'll call this 0_bank account. And so all we're going to do is we're just going to return an instance of bank account with an initial default value of 0. And then we'll create one more fixture. And this one is going to return a regular bank account with an initial value. And what value we want to give it, we get to decide. So I'll just say return bank account. And in this case, 50. All right. And so now what we can do is for all of these tests, I don't need to initialize them here because I can have these guys reference the fixture. So to assign a fixture or have a fixture get called for a function, we just pass it in as an argument. So for test bank account set initial amount, we're going to reference the 0_bank account fixture. So what exactly happens is when PyTest goes to run this test case, because it sees this as an argument into the function, it's going to, that should be a 0. Okay. But what it's going to do is it's going to call this function before it actually runs the test case. So it calls this function, and then whatever we return here, which is the bank account, gets passed into a variable called 0_bank account. And so now, instead of creating a bank account instance, I can remove this and I can reference this variable, which is 0_bank account. So let's test this out. Let's see if that broke anything. If we run this. Oh, sorry, guys. Let me undo this. I didn't mean to use this function. This is going to be for the test bank account default amount. So we want to remove this one. My apologies. And we don't need that in this one. And then this will be 0_bank account. So now all tests should pass. All right, so everything passes. But if you're still a little confused as to what exactly is happening behind the scenes or what is the order of operations, I'm going to add a few print statements. So I'm going to say testing my bank account. And then I'm going to put in a print statement inside my fixture as well, which is say creating empty bank account. And so now if we run this, I want you to take a look at the code. And I realize I have to pass in the -s flag to see the print statements. All right, so here we go. We're going to test bank set initial amount. Sorry, no, test bank default amount. And so you'll see that when we start this test, first things first is we create an empty bank account. That's that print statement for the fixture. So before the test even runs, we call the fixture because we've defined that here by saying, where is it? That it's going to be an argument into the default amount test case. Then after the fixtures run, which is just a function, we then run our actual test case, and then we get the print testing my bank account right after that. So once again, just to really drive home this point, a fixture is just a function that runs before a specific test case. That's all. But the great part is we can use the same fixture for all of our other tests. So let's go to the next test, which is setting an initial amount. And in this case, we have this fixture right here, which is the bank account one. And so I'm going to say this is going to go to bank account. So this will call the bank account fixture, and then we can remove this line. And we can just keep this here because it's referencing this variable now. And this should work now. So we run this, once again, all tests pass. And I can just do this for all of them. So I can just call the bank account fixture. And I can just remove that line. Everything else can stay the same. And the same thing here as well. And finally, for the last one, we can do that. And so now you can see that we have saved ourselves a couple of lines of code for each function. And if I run this, you can see that all the tests pass. So at this point, you're probably thinking, this doesn't really look like it saved us a lot of code or a lot of, coding out. However, there's going to be certain things that you want to do that you want to initialize before every single test of your entire application. So maybe something like setting up a test database, right? You'd want that to be set up for each single test. Having to manually do that for each test case would become very cumbersome. And then the lines of codes that you're repeating start to become a serious problem. And that's really one of the best use cases for using fixtures is something like setting up a database or setting up, some sort of email service or something that you're going to use across a lot of your tests, and then having to initialize that manually for each test is going to require a lot of work. And so that's where fixtures really help save us some time. Okay, what I want to do is I want to create one more test. And this test is going to be a little bit different. I'm going to call this test about bank transaction, maybe. And so this is going to test us both depositing money and withdrawing money in one test case so that we can have a couple of different actions on a bank account. And so just like we've done before, when it comes to setting up a fixture so that we can retrieve an instance of our bank account class, I'm going to do the same thing, but we're going to use the zero bank account. So it starts out with no money. And then what we're going to do here is we're going to reference the zero, and we're going to start off by depositing money. And let's say I'll deposit $200. And then we can also then withdraw a certain amount of money. So now we're testing both in one specific test case. And I'll say I'll withdraw 100. And we know that we should ultimately be left with $100. So we'll do assert zero bank account dot balance equals 100. So let's test this out. And let's see how this works. And that works as well. But what I wanted to do is, for this specific test case, I wanted to show you that we can use fixtures and parameterize so we can test multiple values like we did for this specific test case. So what I'm going to do is I'm going to copy this so that we don't have to type this all from scratch. And we're going to create a couple of different test scenarios for this specific function. And in this case, we're going to have a deposited, we're going to have a withdrew, and we can have the expected amount. And keep in mind, you're not limited to having 3 variables. You can put as many as you want. It just happens to work out that I only need 3 in this case. And then we can provide some test data. So how about the same one we have right now? We're going to deposit 200, withdraw 100, and we expect 100 in the end. We can do the same thing. How about deposit 50, withdraw 10, and we should end up with 40. And then we've got our high roller, which is sitting there with a whopping $1,200. And he withdrew, how about 200? And he's going to end up with $1,000 at the end. And so now we can pass deposited, withdrew, and expected. And now we can use deposited here, withdrew here, and then we know what the expected is going to be. So let's try this out. All right, and we can see all 3 test cases run, and in this case, all 3 test cases passed. So I just wanted to show you guys that you can use this with our fixture. So it's okay if you're using a fixture, you can still use the parameterize decorator in this case to test multiple scenarios. If we go back to our bank account class and you take a look at the withdraw method, you'll notice that right now we're not performing any check to make sure that the user has enough money. And that's not really how a bank account works, because if you have $100 and you withdraw 500, the bank's going to be like, we can't do that. So it just makes sense in our code to actually perform some sort of check. And so usually, something simple is we'll say, hey, if amount that you're trying to withdraw is greater than your balance, well, what are we going to do? Well, we're probably going to raise an exception. So I'll say raise, and we're just going to raise a standard Python exception. And we'll just say something, hey, insufficient funds in account. Right? However, if we do have enough money, then we will actually perform that operation. So this is all good. If we go to our test calculations, and we just add one more scenario in this case, but this time we deposit, let's say, only $10, and we try to withdraw